where are we going there? I might just move this bloke here. Can you move to there, please, sir? Because you're right in the way of my beam. We can't have that. Thank you. Oh, hang on. We've got to... Bloody hell. I've got to press a button. Righto, that's all right, don't worry. All right. There we go. So that's me. That's when that was just after I had my last haircut and a shave. And yeah, we've been doing the permaculture thing since 1993. I started my business in March of 1993, started designing my first properties, and then in November of 93 I thought I'd better go and do a permaculture course. So I did what most people don't do, and I started my business before you actually did the course. Since then, I've designed actually now over 1,200 properties. We've been clocking up a few since we've been around the joint, and you know, back in the early days, I'd pretty well design anything, but I've had the pleasure of designing some really big properties now as well, like up to 110,000 acres and 26,000 acres and all of that in between. Most of my work in Australia is on properties between sort of 20 to 2 to 5,000 acres. That's the sort of average, if you like. My wife and I are really, as we say, we're doing this for life, and as a motto, there's nothing else we can do or could do. I mean, I'm actually a chef by trade, and that's what sort of drew me to this stuff. Was I like food, and part of that was after I left the chef game, because it's a terrible. Anyone who's been in hospitality knows it's a young man's sport, or a young person's sport, or a crazy person's sport, and so we got out of that, and well, I got out of that. My wife was also in it as well at some stage, and I got into organics through the restaurant industry, because back in the 80s, as you probably imagine, back then, you know, organics wasn't what it is now. Like all of the supermarkets didn't have organics. Not everyone was on that sort of bandwagon, and to get the sort of quality food that we wanted to get in the restaurant game, you know, that sort of diversity, you know, just even to get something that had colour in a lettuce, you had to go to an organic farmer. So that sort of rekindled my interest from our farming days, where we had the big garden and all of that sort of thing from the family farm, and so that got me into that. And then before I knew it, I was out of the restaurant game and managing an organic greengrocer. So I became a grocer, and then I started dispensing advice over the counter to also dispensing advice to farmers that who were suppliers to us, because I just can't help myself, and so was able to back in the late 80s, early 90s, meet a huge array of what I'd call vanguard mavericks of farmers, because back then, you know, it was a very marginal activity to be an organic farmer. It's sort of almost de rigueur to sort of be thinking about, you know, that's a very viable option these days, but back then, you know, you really had to stick your neck out. And so we met some really good people back then, and those people are now formed, like Australia's got the largest area under organic cultivation of any country in the world. So from small beginnings, these things go quite large. We've had the pleasure of working with a whole range of different organisations, and one of my logos has dropped off. I don't know what happened there. There's one there, the Shell Oil Company's missing. What's happened there? Anyway, we did a bit of work for them. I designed their oil refinery of all places. Not the oil refinery, but all of the land around the oil refinery out of Melbourne, about 400 acres. We put in lots of forestry and dealt with all of their effluent and all of that sort of thing. That was a bit of fun. And yeah, we've worked all over the joint with all sorts of people. This is the part of the world that we're from. It's actually a probably a similar latitude to just south of San Francisco, about Santa Cruz, 37 degrees of latitude. Where our climate's probably similar to maybe Bakersfield, a bit not quite as cold perhaps, but certainly as hot, or maybe a bit hotter. Does Bakersfield get up to 125 thereabouts? It'd seem it anyway. Feels like it, yeah. And in my childhood, our rainfall was about 20 inches, 18 to 20 inches, 25 inches thereabouts, in that sort of band. Winter rainfall like here. And it in the last 10 or 15 years has dropped by about 50%. So global weirding, warming, whatever you want to call it, has struck. And as they say, you know, this part of the world, southeastern Australia, is likely to be one of the spots that is really hit by global warming the most. And we don't need any help because of our latitudinal position and because of our proximity to cold sea to make our climate any worse than it actually is. So part of our tour is actually to maybe look for alternative places to live. Because Australia, well, at least our part of the world where our family's been for 150 odd years, is going down the tube big time. When I left, I live in a town on the outskirts of a town about the size of Santa Barbara, and the water storage was at 2% just before I left, right? So 2%, you know, 2%. That's when you put a straw in a cup and you're going, you know, and what you're getting up out of there is pretty dirty muck, you know. So it's pretty expensive water, and so the government's known about all of this, that it's going to happen for some time, and their reaction is to go and build a pipeline that'll take water from an irrigation district. That irrigation district, its main use of water is in irrigating dairy country in a desert, right? And then the factory that all of the people, all of the local milk co-op, their major output is dehydrated milk powder. I think that's very funny. So they use all of this water that we've got none of, and then they just dehydrate it. Yeah, that's you can only laugh at such stupidity. Anyway, this is where I grew up, and thanks to my mother and my uncles, they sold the family farm before I had a chance to get it in 2002. But I bear no grudges. Just get that knife out of my back, will you, young fella? Anyway, I was lucky. I was lucky, fortunate in one way and unfortunate in another. My father was killed in the Vietnam conflict as a conscript in 1968, and so I had to grow up on my maternal grandparents' farm. And my grandfather was a pretty radical guy. He was a farmer socialist. He used to tell me that he was to the left of Trotsky, and that it was, you know, to profit was to steal, and all of that sort of stuff. But we all did that on the front veranda of that house with the national park in front of us. So it was a pretty nice spot to be musing such things. But then I'd go out there, as when my mother remarried, we moved into town, but nearly every holiday I had, we'd go out here, and I'd be dropped off. And I was the eldest grandchild, and you know, like this pond here, I built with my grandfather in 1981 as a 15-year-old. And Mum dropped me off out there, and Grandad came up to the fence and he goes, "Oh, I've got a bit of a job for you." And it involved a grey Ferguson tractor and a scoop. And so a 1 yard bucket, and I wasn't driving the tractor. I was on this scooping this bloody thing out, which is, and our land's pretty rough, or what was our land is pretty rough. You can probably see I might zoom in a bit, you can probably see on all those little pieces there, they're little pieces of shale. It probably should never have been cleared, actually, this country. And so it's pretty hard going. But we had all of these dams on our property, and they all collected rainwater and then distributed them around the property very elegantly. And then basically the large valley that ran through the centre of our property was irrigated by all of these holding ponds that were all held at the highest points around the edges. So that's why it's all green down the centre, because all of these ponds are actually, just by gravity irrigation, harvested the rainwater over winter and let a fair bit go through as well, so there was a bit of an environmental flow, as it were. And then when we needed it, like about every month, we'd let the water out, and we just had a little channel, and you'd just go along with a shovel and just put a sod of soil in there and watch it run across the surface. And to me, I just thought, well, that was, totally natural thing. And then I came home one day after I'd done my permaculture course and said to Grandad, I showed him the permaculture manual, and he's looking through it, and he gets to Keyline. He goes, yeah, that's what this is. That's what we've been doing all this time. I read the books back in the 50s, and there you go. But we had forestry and everything. We had, I think we had about four blocks of forest on the property, all at different ages. Our native trees are the same trees as that grow here, like Eucalyptus polyanthemus, Eucalyptus tricarpa or sideroxylon, as you probably know it, red ironbark, red box, yellow gum, etc. They all grow here. That's the native climb of it. And we managed all of those for fencing timber mainly, but also for other farm building timber. And that's another thing that, as I've been talking to Gunnar, when I first came here, I'm going, wow, you've got all of this stuff here, all of these beautiful Australian trees, but no one knows how to bloody use them. No one respects their value, especially the ironbarks. They're a tree that are 100 years in the ground without rotting. They're one of the strongest timbers in the world, and you've just got them growing as street trees. And you cut them up into blocks for firewood. Yeah, unreal. It's very good firewood, but it's a bit of a waste, really. This is our tour so far, and our purpose of our tour has been to consult with the landscapes and communities of the world, and because, like I said, we're sort of interviewing the planet to see if there's a better place. We're not looking at Mars or anywhere like that yet. We've got to talk to our mate Dick Branson about that, and well, it's also to facilitate an increase in awareness with respect to the practice of what I call broadacre permaculture design. Most people in permaculture focus on their backyards and their sort of urban stuff. It's never really interested me that much. I come from a farming area, and to me the most effective use of my time as a designer and a developer has been on working on the largest landscapes that humans work on, which are agricultural landscapes, and that's something I've been throwing down as a challenge to all of my students and people who come along to these courses who have any influence to work on agricultural landscapes, because it's the most pervasive and potent industry on this planet in terms of our greenhouse output and in terms of our energy consumption in food production. So it seems pretty crazy that we're just leaving it alone. And also to inform people about the most effective means of sequestering atmospheric carbon dioxide, and that too is also through agriculture. agriculture is by far the largest contributor of greenhouse gases. Some 470 gigatons of carbon dioxide has been emitted by agriculture compared to 250 gigatons that have been emitted by fossil fuels. Yeah, Al Gore sort of forgot to mention that. So as most other people, agriculture's got off pretty free. So, and most of that has been just by plough-based agriculture and by killing of soil. When you kill soil, you basically kill the humus in the soil. The humus oxidises. Carbon and oxygen mixed together are called carbon dioxide. It becomes atmospheric. The ploughs help to turn it into dust, and up she goes in a plume, and a lot of it. So, but fortunately we can get it back very quickly. We have some very good techniques. Now, there we go. Now, permaculture as I've got all snazzy now. I resisted all of this fancy PowerPoint stuff, but I finally succumbed. Now, permaculture as an integrated broad-acre biospheric design system. It deals with all of the spheres: the lithosphere, the land, the atmosphere, the air, and the hydrosphere, the water. And permaculture has a system of ethics and principles. And when we're looking at it from the perspective of broad-acre, we're looking at also including things like keyline design and other modalities like methodologies from people like ZERI, the Zero Emissions Research Institute, who are doing fantastic work at checking the limits of yield, actually pushing the limits of yield, and very, very interesting integrated agricultural systems. Some of which you might be aware of, like simple stuff like dairy farms that have, that instead of just being methane farms, the methane that is now being captured in biodigesters. And then that sludge then goes off that produces electricity as opposed to just becoming atmospheric, which then powers the needs of the dairy. Then that effluent from that, the sort of anaerobically treated sludge, then goes off into producing mushrooms, and then the waste from that then goes off to feed fish, and so on and so forth. So you get on one enterprise these you're really trying to limit the amount of emissions that come off it. As they say, pollution is just unused waste, and they do a fantastic job of doing that. Also, there's the science of holistic management, as per Alan Savory, which is a fantastic method of rangeland management, which fits in very, very well in our broad-acre model of permaculture. And also the very latest stuff as far as carbon farming is concerned. And what we're trying to do is have all of these actually work together. Isn't that snazzy? I know you like it. Now, next time I come back, it's a work in progress. And this is what happens when I sit on a plane. I get all bored. And I think, oh God, I've got such a tired presentation. I've got to move this on. So now carbon farming is a very interesting thing. And we've got lots of other elements that are working with this stuff, and like soil food web, Elaine Ingham's work of soil food web. We've got the keyline stuff, like I mentioned. There's the mycological work of people like Paul Stamets in particular. So there's all of these other fantastic methodologies out there that are really feeding in to what I see as these four cores that work in, as we would say, as our toolkit, as part of our toolkit for broadacre permaculture. Carbon farming, my goodness, isn't that a good thing? We can sequester an enormous amount of carbon in soils. Just to give you a bit of a brief, now I stole this one, be careful if you've got one of those promiscuous little sticks, you know these things? Yeah. This one's actually got a prophylactic. It's actually protected. This one's unguarded. And if you've got one of those things, then they're pretty dangerous. You can grab a fair bit of stuff if you're not looking. Anyway, David Holmgren wasn't looking. Yes, he was. He gave this to me. And just to give you a bit of an idea about permaculture for those of you who are not familiar, permaculture deals with a whole range of different human settlement systems and deals with our land use and stewardship, built environment, craft, technology and tools, culture and education, health and spiritual well-being, finance and economics, and our land tenure and community governance. All of those things together form a pretty dynamic system that all revolve again around a system of ethics and principles. Now, the ethics are care of the earth, care of the people, and return of surplus or reduction of consumption. And there's many principles that are specific to permaculture, like each element performs many functions. The use of biodiversity, each element is supported by many functions. And what I like the most is that yields are only limited by your imagination. The human brain is an amazing thing, and where it's used for good or for evil, it's very potent. And there's Jeff Lawton, and this is a cracking saying from Jeff Lawton, one of my colleagues. He says, we can be just as positive as we can be as negative, which is exactly what I want to talk about from the perspective of our development on agricultural landscapes. So the key figures in terms of permaculture, there's a few now, but as mentioned before, Bill Mollison. That video, by the way, Wes, just to correct you, is called In Grave Danger of Falling Food. Yeah. And yes, you'll enjoy that Australian story. Bill was discussing, I think, his relationship with his mother, which wasn't too good. Anyway, so Bill and David got together and did the permaculture thing in the 1970s. But of course, a lot of that was founded by, as a lot of this stuff is a process of what you would call incremental design. And, people like P.A. Yeomans was one of those who coined the terms, or used the terms permanent agriculture well before permaculture came along. Your own J. Russell Smith in 1927 wrote a book called Tree Crops, a Permanent Agriculture, which was one of my all-time favourite books. And I use it all the time still today. But this bloke here, P.A. Yeomans, Percival Alfred Yeomans, he was just known as P.A. for obvious reasons. He was a mining geologist, and he observed peculiar landscape features, and also as a miner as well. Anybody who's involved in mining understands how to use water, how to harvest water, because in a lot of places where in most places where you're mining, you use a lot of water to wash the ore away. And you've got all the tailings ponds, and you've got to harvest it. And often in Australia, these landscapes are out in the middle of, as I would say, whoop, out in the middle of nowhere. So there's no water, and the water that we've got underground, we've got a lot of underground water like you do here in the United States, but it's all salty. So to use that in a mining environment would only increase the environmental damage that mining already does. So you have to harvest the water that actually falls on the landscape. It's called rainwater. I laugh because you guys have just not even got close to capitalising on the amount of rain that actually hits this roof called America. It's quite unfathomable. Well, what's really unfathomable is that, we were out in the Kiama River Valley the other week doing a permaculture course, and they're down to 1,400 feet, pulling water up from that deep. And it's getting saltier, and it's getting more expensive, and that's just to water your organic carrots. Yeah. Yeah, real organic. Anyway, So this bloke really understood water harvesting and moved it into his he became a farmer and developed his system for rapid topsoil development based on another American called Louis Bromfield, who some of you might be aware of. Louis Bromfield wrote books back in the 40s and 50s. Malabar Farm was the most well known. He could have been I think he was on Adlai Stevenson's ticket in the 1950s. He could have been your Secretary of Agriculture. Isn't it funny? A soil builder becoming your Minister for Agriculture. Yeah, that would have been interesting. I wouldn't be here. Yeah. And we had the rainwater harvesting and gravity irrigation system, and also integrated farm layouts based on the farm's topography, so respecting the land's patterns and then developing them accordingly. Pretty interesting stuff. Now, just to give you a bit of background, I've been mucking around with the Keyline plough for a long time. And I do all sorts of weird and wonderful things with this machine. I push that yield envelope and try and achieve multiple functions from every element, including like this machine. This is one of my latest things down here, planting 5,000 plants per hour into pasture, just for fun. Also this sort of thing where we're doing the injecting pipe into the ground so that we can gravity irrigate plants and overcome the vagaries of climate. That works pretty well. We ended up getting a plough sent out here by the Yeomans Plough Company. This is up at Gunner's place at Aurelia Ranch, just up the road here. Not a bad place to plough. That's why I'm turned around this way, because if you turn around the other way, you're watching the dolphins go by and all the waves. And Gunner's never there because he's always catching a break. And that's why I'm doing all the work. No, we're having a bit of fun there. Gunner was there all the time. I had to pull him kicking and screaming out of the tractor seat to do this bit of ploughing. Not a bad spot. But this is the latest expression of the Keyline plough. It's a pretty nice machine. And that's now living on a property up in Marin County, doing a bit of work, and we've got a plough down here as well that we'll be doing a bit of work with on the weekend. Some of my work, like I said, has been broad acre, and this is this is about a 1,500 acre property in 1997, and before then, I think it was 96. Up to that point, we were doing about 20 designs a year, and doing most of them by hand, or doing them all by hand. Anyone who knows hand drafting knows it's a pain in the proverbial, and very time consuming. I did a whole farm planning certificate course at Melbourne University in 1995, and I first saw this computer-based mapping stuff for the first time. And this bloke could just click and it would tell you how big an area it was, and how long a line was, and you could draw fences and all this sort of stuff. I thought, geez, this is the sort of thing I want to have. So I got myself a copy and never looked back. And from then on, I was able to do upwards of 100 designs a year, because you could do things so much quicker and more accurately and all of that sort of thing. So we're encouraging, as part of our work in permaculture, in Keyline, etc., for people to adopt this sort of stuff. A lot of what I'm doing is actually just trying to show people what our successful business model, which is got us to the point where we're working internationally and developing actual farms, which is pretty cool. And our business model works pretty well at doing that. So I'm probably almost selling a bit of a franchise, or showing a franchise, but I'm not selling it. I probably should. as anyone who knows me well, I give most of my stuff away. Anyway, we got to the point in '98 when we were getting really busy, and I really stepped up a level, and we needed to hire a surveyor. So I had a surveyor that I had full time. I picked him up in a mine, as you pick most people up, and well, it was good because he was a miner and he didn't like working in the mine. Nobody bloody likes working in a mine. And he had all of this ability to design dams, as you'll call ponds, I call dams. And also, as you'll see here, you see all those dots? They're actually a mine blast pattern, because the software that we use to design this is all, those dots are where you put the gelignite charges. So, well, in my case, they're trees. Although it sort of excites me to use gelignite as a ground preparation method, but I haven't got to that point yet. Yeah, so we get to doing some pretty snazzy stuff, and you know, we've been very fortunate that working on the edge with a lot of people who are innovative farmers have allowed us to push some boundaries that have never been pushed, and do things that have never been done before, and paint landscapes like they've never been painted before, and do it in such a way, because I do all of this stuff based on a bottom line, and that's where the holistic management stuff comes in. You know, you set a goal, you go through the process, and you determine, you know, is this actually a viable thing to do? So we spend as much time designing as we do doing spreadsheets, working out, you know, is this actually a viable thing to do? And, you know, this is an expression of some of that work where we're designing systems that are actually very economically viable. And that's been something that's been levelled at permaculture over time, that permaculture is not an economically viable activity. Well, that annoys me a bit. And I don't like people telling me that what I do is not worth a quid. And so we go out of our way to make sure that that's not the case. But to be reasonable, a lot of the systems that we've developed and tested have had to go through some sort of incremental design in itself. We've developed a whole range of different standard designs that we know work. We test. We've got a few farms that we test, farmers that allow us to do research, and who do their own research, because when you're an innovative farmer, you just need a bit of a help along, and we do that, and then they start to really breed on that, and then you go out there one day and they've done something absolutely radical. It works really, really well, but they've made a lot of mistakes as well. So we work with it when we're working with the rank and file client. We do it in such a way that's usually using best bet standards, as I would say. So we limit the amount of risk. I work for a company called Mars as well. I'm contracted to them forever. Well, that's what the confidentiality agreement says anyway. And I have to basically, you have to go through this screen later on, which will erase your memory as you walk out this door. Because I'm not meant to show you any of this very confidential material. But however, the inner anarchist in me, this is a project I've been working on since 2004, and it's Keyline inspired. It's water harvesting and also soil harvesting and soil building, which are, you know, the real fundamentals of Keyline. And it's called a sustainable cacao agroforestry system. Our intent is to, our first intent was to stop 300 metric tonnes of soil being lost per hectare per year. That's about equivalent to 67 40-foot ship containers of soil every acre per year being lost off the site. Oh my God, yeah. Just peeling off the layers in hot rain. So we did that straight away. That wasn't too hard. And now we're actually building soil, which is not too hard either, where you know what to do. And we're also saving lots of water because all of that water that was running across the surface, taking all of the soil, now gets held in dams. And those dams are now made water available not only to our project but to the community around it. So it's a drought-proof community now. Whereas before, even though it's something like a 60-inch rainfall zone, all of that rain comes in just 4 or 5 months of the year, and then it's dry as a bone, dusty and bone dry. Whereas now, they've got more than enough water to do all of their agricultural activities. They don't have to pull any out of the ground. Like you guys, that's what they do. They get all their water from underground. But unlike you guys, it's not illegal to actually harvest rainwater. So we've made the most of that. And we even built rainwater tanks. How about that? Rainwater tanks that you can use for drinking water. What a novel concept. Yeah, so we had a lot of fun there. Cleared up all of this country. It was all bamboo, and that's actually 4 months from there to there for our research site. Pretty nice spot. And we built the rainwater tanks that harvest the water off their own roof using ferro cement. Trained up all the local bricklayers how to do all that sort of thing, because they were they're plasterers. They do plastering of bricks and whatnot every day, so they were the natural candidates for this sort of work. So we got them to work. Now they go around and build these structures for people all the people in the villages are now getting rainwater tanks. We worked out what the ideal size was. We asked the farmers how much water they need every year, and now there's a standard tank, and it costs about $300, about the cost of a television. Yeah, so which is pretty cool. We have a bit of a crack at engineering as well. One of our dams didn't hold too much water, so it was very porous clay, so we got to work on fixing that. And this is a 50,000 cubic metre storage, which is about, about 30 acre feet of water. And that supplies a village with all of its water now. It's got a 4-inch PVC pipe that comes out of it, and there's an overhead pipe that people can come along with their little carts and just go psh, and fill it up and run away. It was sort of a bit outside of the original mandate, but you let an Australian loose out in the bush and you never know what'll happen. I was just there to grow some cacao and save a bit of soil and water, but anyway. They're pretty happy though, thank goodness. This is sort of stuff as well as another expression of broadacre keyline and permaculture, where we're stacking functions. We've actually combined alfalfa and olives together, and we've done this in a keyline layout. So what I mean by a keyline layout is that all of the rows are not on a contour, they're on a slightly, what I would call a falling contour, if you can get your head around that. That all of the water actually runs from the valley out towards the ridge. Keyline, when expressed in that way, is a system of rehydrating the ridges, because most of our work is actually in dehydrating the ridges of our landscape. And most of our landscape that we use is actually ridges, so it seems pretty crazy that we dehydrate most of our landscape. Yeah, it's actually pretty insane really, but anyway. We do that with forestry, we do it with olives, we do it with pastures, all sorts of things like you can see here. And with vineyards, all sorts of different systems that we use this kind of system with very good results. I mean, this is at 15-inch rainfall, and that's a 6-year-old tree, which is not too bad. That's an Acacia dealbata, which is a species that you have growing right here in Santa Barbara. It takes you a bit longer to grow that because you dehydrate your ground, and I'm actually increasing rainfall. Because, a lot of your rainfall actually just runs off, especially when your soil's hard. And then you're sort of scratching around for the rest of the year wondering when it's going to rain next. sort of makes sense to take advantage of it when it hits. Yeah, and that's the result. You get accelerated growth, and you get a bit of timber before you know it. Oh yes, well, I'll move on. I put my Land Rover. I've got a Land Rover Discovery, which to some people might be a bit of a poser of a car, but to me it's a machine that I can sow a paddock with in utter comfort. Like an English gentleman I am, with my rickety machines out the back. That's what they're designed for, really. And we have a muck around with all sorts of things and playing with different machines. This one here, subsoils to 26 inches and then tills the soil and then pulls up a mound using a 55 horsepower tractor. So instead of using these big, very, very fuel consuming machines with multiple passes and lots of compaction and all of the rest of it, we put all these things together. I mean, that's something that the US agriculture hasn't got their heads around yet. In Europe, where fuel is something like $6 or $7 a gallon, they have multiple pass agricultural equipment. So you don't just have a chisel plough, you also have a cultivator and you have a seeder, all passed in one. You know, I was driving down from San Francisco this morning, through all of the market gardening areas in the Salinas area and whatnot. And there's all of these people out ripping, and then they're going through and doing another pass and another pass, and it's all of this. You can see where all of the fossil fuels are going, and you can also see all of this dust that's being raised, and that's all of your carbon out of your soils, which is all being oxidised. So, you know, we have a duty not only to the amount of fuel that we use, but also to the soil that we use, that we're losing it. We're not only losing our fuel, we're losing our soil from all of this passing. This is another one. This machine plants 5,000 trees an hour straight into pasture, which is a bit of fun. It's actually not... you're sort of going about this sort of... Actually, no, it's about... You get to... It's a bit difficult for me because I'm a bit of a dyslexic. So it's a bit of fun. That's George. George is one of my major clients, and he's a bit of a character. And he sponsors a lot of research. We do a lot of research. We test a lot of stuff out on his farm. He's got about 500 species of plants on his property. This pasture here has something like 120 species of pastoral species in it. We're basically recreating a herbal ley meadow system in a dryland climate. Something that you'll all become the benefit of. You'll be the beneficiaries of that sort of research in years to come, because we'll be sharing that with people. But we're testing our stuff here, and having a bit of fun. That's where we've been. Can't see where we've been actually. Anyway, all sorts of stuff. That we've got peak oil, we've got peak water, we've also got peak plastic, which is really going to scare me because I love plastic. And so we're growing plastic trees on our research farm, and we found that they benefit from mulching, and you get increased growth rates also from nitrogen fixing cover crops. Very well, very, very good indeed. Especially peas, they like peas, and they grow really well. So, yeah, you should get onto that. That's the latest thing. Now, here's Yeomans again. Now, Yeomans, he died in '84, so I didn't have the pleasure. But these are the books that he wrote or influenced. And in 1953, he wrote a book called the Keyline Plan, which was the first book on functional landscape design ever written. And it's still one of the few books on functional landscape design ever written, unfortunately, and that part of your library is not that big. And it's still a landscape that we don't see much of. Certainly didn't see any of it driving down today. We've got a little bit of over in Australia, but not that much. It just goes to show, I mean, I've done an enormous amount of work, you know, planted millions of trees and worked on all these farms and whatnot, and, you know, I'll never run out of work. And if every one of you are here in this room did the same as me, you'd still never run out of work. I mean, the level of land degradation on this planet is just unfathomable. And if you're someone like me who drives like this, you know, I'm not a good person to drive with, you know, a bit dangerous. I'm always looking out the window at these landscapes because that's, like today, I've got California redesigned. It's if you let me do it, it'll be okay. But the idea is not to let me do it, is to let you guys all do it. And the real idea is actually to allow the farmers to do it themselves. You know, they've got their, you know, sustainability is illegal after all. And, you know, so is water harvesting on farmers. You know, it makes it really difficult for farmers to actually develop sustainable systems when we've got such ridiculous laws in place, and especially regarding water. Fortunately, at the moment, there's no law against creating soil. I'm still waiting for that. Anyway, but there's very few trees in our landscape. I think we're allowed to plant trees, aren't we? That's something we're allowed to do. We're allowed to create soil. We're barely allowed to not use chemicals. At least in Australia, a lot of the banks stop farmers from not using chemicals. I've got a good joke for you, actually. Well, you mightn't think it's that good because of my sense of humour. What's the difference between God and an agronomist? You don't know? Of course you don't know. God doesn't think he's an agronomist. You could probably say the same, you know, what's the difference between God and a permaculturalist? Well, you know, that would be quite fair too. But a lot of our landscapes are there ripe for the picking, and all of these books and all of our permaculture stuff, I mean, all of it's there. We really don't need to go looking. We've got enough knowledge to do all of this stuff. It's just a matter of having the key people who make decisions about allowing this sort of stuff to allow it to happen. So 58, we've got the challenge of landscape. 68, you've got water for every farm. Really good book, that one. And then 71, Yeomans writes a bit of a cracker called The City Forest, which is where he applies the Keyline water harvesting scenario planning tools to city landscapes. Now, someone just said tonight that you've got all these fires and everything threatening your poor water systems because you've got all of your eggs in one basket. Another ridiculous act of modernity where we put all of our eggs in one basket. Like we have one reservoir or two reservoirs for 100,000 people, and no one has rainwater tanks, and no one. What was the catchphrase? You know, stop it, store it, and sink it, or something like that. One of those things. Spread it. Yeah, all that. Slip, slop, slap. Yeah, that sort of thing. You know, it seems quite bizarre to me when you've got 90 to 100% efficient runoff surfaces in cities, in towns, and you've still got the same landscape as you have in a farm. You've still got the same opportunities to harvest and catch and store water in cities, in both open bodies of water as ponds and also in tanks and all of that, but no one does it. I mean, it's just, and yet, you know, it's quite likely that as a result of losing all of that forest up there, that your trees, that you've now got no trees up there, that's going to reduce the amount of rainfall that you're going to get straight off the bat. It's going to increase the amount of runoff, but it's also going to increase the amount of silt, which is going to fill up your bloody reservoir, isn't it? And you're going to be left wanting, which is a bit crazy. And then you're going to have engineers running around doing what I call designing on the run, sort of crisis management. When we've got more than enough water hitting this town that's not being harvested, that's not being made available, and therefore having multiple resources as opposed of multiple options for water as opposed to one or two. An animal that lives in dark, deep, dank places, like billabongs. Now, some of you would only know what a billabong is because you've got a pair of board shorts or a shawl or a hat or something like that from the surf company. A billabong is actually a water hole by a river or a creek. When the river floods, it leaves behind all of these water holes, and they're dark, dank sort of places filled with debris and crayfish and yabbies, all that sort of thing. So that's what a plough does. It ploughs underground where it's dark and dank, and hopefully dank because we're increasing the amount of water penetration and holding. The slipper is because it's got a point on the shank, and that point is like your slip-on shoe, right? And the imp is for implement, and the shake aerator. It's like Brad Lancaster's abundance. You know, it's a shake-aerator. A shake-aerator is a device that is basically, you can just see it. We might magnify it in there because I know you're awfully interested in farm equipment. I can see that you're riveted. See that little yellow thing in the centre there? That's used to be a recycled truck flywheel, right? Big heavy thing that keeps your crankshaft balanced, you know, keeps it, got a lot of centrifugal force when you've got a big heavy bit of metal spinning. Well, Yeomans, must have woke up one night with a bit of an idea, and he counterweighted that flywheel so that when it was powered by the power takeoff of the tractor, it spins and it's putting a vibration through the plough, so it reduces the amount of horsepower that's required. It's like if you can imagine using a jackhammer, because I know you've all had a go of one of them. You use that, and it's just a stick until you turn the motor on and it goes and it starts digging. It's the same thing here with this machine when you've got the shake-aerator. So it increases the amount of shattering, as we call it, of the subsoil, and cause a little mini explosion underground. Very good thing. Now, Yeomans' youngest son, Ken Yeomans, in 1994 wrote this book called Water for Every Farm, which sort of got all of the old books and put them together. Not a bad book. It's a bit hard to read, but worthwhile as a publication. You can get that off a website called keylinedesigns.com.au, and as an e-book or as a hard copy. Now, Allan Yeomans, PA's middle son, inherited the plough business because Yeomans was a bit of an entrepreneur. He not only had the farm design business and also had two large farms totalling about 1,500 acres that were full developments of all of this stuff. He did design consultancies, and he also made ploughs and a few other bits and pieces. And I think he still did mining stuff as well. And he developed this plough, and then Allan, his middle son, who was a mechanical engineer, came into the fold after spending some time as a mechanical designer and builder and all sorts of other things, and as an inventor. He invented something that you've all used. It's called a banana lounge. Does anyone here know what a banana lounge is? The banana lounge is one of those things, those terrible aluminium frame chairs that go, they fold up and they go click, 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 click. And they always break, you know. Yeah, he invented that. When you ask him what his important claim to fame is, it's, I invented the banana lounge. Yeah. Anyway, he works on these ploughs now and he's quite an innovative chap. He's also written this very controversial book called Priority One, How Together We Can Defeat Global Warming. It has some very powerful messages about agriculture's role in terms of both cause of global warming, or one of the cause agents of global warming, and also how much promise it has in actually solving the situation. But it's also got some stuff about recommending nuclear energy and about that it seems quite valid to remove rainforests because they're going to go anyway, and have massive biofuel plantations, etc. So it's an interesting book to read, and you just got to sift through your various opinions as you go through, but certainly worthwhile reading in my opinion. Now those books of Yeomans which are out of print are actually available through this website. Now I've made a mistake on that. It's actually just soilandhealth.org, not .au. And they've got a huge range of out of print books on soil and health, and all of the old classics, like all of those ones that I know you're chasing up, like Newman Turner's pasture books and Andre Vasson's animal husbandry, all of those sorts of things that I know you're just very eager to get. They're all on here. You don't have to go to the antiquarian websites to get them. Very, very good site. You've got lots of stuff on health as well, you know, a lot of those old out of print texts. Now Yeomans framed something that was probably a bit of a precursor to the principles of permaculture, and really created something of a framework for the prioritisation of design of our landscape. And interestingly, called the scale of permanence. And number one there is something called climate. And what the relevance here is that number one is the hardest thing to change. And number 8 is the easiest thing to change. But what's interesting from this scale of permanence is that soil has the greatest effect on climate, and climate has the greatest effect on soil. It's the opposite ends of the spectrum. And it's been our enormous human team effort which has been fantastic. I mean, it's an unprecedented human effort in trying to destroy our climate that's done a pretty good job. And if you go to West Virginia, you can sort of see where they do a bit of a job on land shape as well. To extract the coal there, they just, if there's a mountain, well, no problem. We'll just get rid of that mountain and you go. But it's interesting that, like water is something that we have fixed amounts of water that are actually in our hydrological cycle. Just as an aside, I was talking to the great Brock Dolman. I've only met Brock the other day. What a lovely fellow he is, of the Water Institute. He did a study. He interviewed people across the United States and to determine their hydro literacy, their literacy on water issues. And he found that only 10% of those interviewed actually knew any part of the hydrological cycle, which is pretty, like, he would ask, what do you know about the hydrological cycle? People didn't even know that rain was part of it, Anyway, I digress. Water is something that we have a high potential to actually correct through modification of land shape, in building small earth dams, in building small berms that actually harvest water off the landscape and then redistribute it. The climate we only have a very small influence over directly. We can plant trees, which will increase the amount of precipitation and collection of precipitation. That's something that we can do, but by and large the climate that we're dealt with is what we've got. With roads, we can manipulate the direction of roads in our design so that they not only follow the appropriate direction, like along ridges and all of that sort of thing, but also that the roads can help with the water collection. Think of a road as a catchment. A road is if it's a paved road, 90% of the water that hits a paved road runs off, is not infiltrated. So they're very, very, very powerful means of actually harvesting water, and that's one of the reasons why we don't want roads in our national forests and everything, because they have that catchment efficiency and they concentrate water. But when we design them well, we can actually use them as very powerful water harvesting features, and that's something that we do a lot of in our work. Trees, as I mentioned, they fit in very well. Buildings and subdivision. Buildings, our placement of buildings is something that we take a bit of care of. And subdivision, what I mean by that is that we divide our sites up. Like where we put our fences is something that we can do quite easily, or with relative ease. But the simplest thing to modify and to destroy are our soils. And like I said, if we don't have good soil, then good soil is the foundation of every civilization. And correct me if I'm wrong, history buffs, but there's no civilization that has survived where it's destroyed its soil. There's no precedence there. I don't think we want to go there. Yeah. Now, how do we improve our soil? Well, the Yeomans method that was, like I said, developed by the likes of a few people, famous English farmers like Newman, gentleman farmers I will call them, like Newman Turner and Fred Sykes and Sir Albert Howard, all of those very early organophiles, as we'll call them, back in the 30s and 40s, really powerful observers of landscape and maintainers of fantastic pasture in the World War II era, pre-industrial fertiliser era. Them and then your own Louis Bromfield, this sort of progressive approach of having a shallow, compacted, drought-prone topsoil and then using some sort of soil test and remineralising it to bring back the excavated minerals from agriculture. Because agriculture, as we know it in a conventional sense, and in a lot of cases in organic agriculture, is an extractive industry. It's no different to mining. Otherwise, why would you have to bring back all of this fertility from elsewhere off the site? There's nothing closed loop about this stuff. It's a sieve. So we have to do that. Then we find where the hard pan is, because there's usually some sort of area where the soil is compacted in the soil, in the strata rather. And once that compaction reaches 300 pounds per square inch, roots do not penetrate. And so we have to actually get through that, open it up, so that plants can reach their physiological potential, which is, what we're trying to do here. We do that at the start of the growing season, and then we remove the livestock for 4 to 6 weeks, sort of until the onset of flowering. At that point, the plant has reached its maximum biomass, both above and below the ground. And then, as Yeomans said, we we stem the reproductive urges of the plant. Yeah, what a terrible thing to do, to have done to one. And what that does is it causes a bit of a root death. Good night. And that's all right. You can leave. It causes a root death because, especially in valuable bunch grasses, in perennial pastures where we actually, the plants are quite old or can be quite old, and that eating down of the top of the plant causes a big root death, root pruning, if you like, and then that becomes food for the soil microorganisms, which are now being supported by the minerals that have been put back on, and also the removal of compaction, which has opened up the amount of air, water and light that's available into the soil as well. So aerobic organisms in the soil proliferate and chew down this stuff and turn it into something wonderful called humus. Yeah, that's all right, which holds a lot of its own weight in water and allows plants to go to depths that they couldn't go to before. And we do something else. We actually increase, like I said, we increase the organic matter. And if we do that, which is very simple, 1% increase of organic matter in our soils equals on 1 hectare, 2.5 acres, equals a 57 tonne reduction of carbon dioxide out of the atmosphere. Now, so that means that if you were to increase your organic carbon or organic matter content on 1 acre of soil, then that would be all of your carbon dioxide emissions for 1 year. And you know how much that would cost you? If you were to pay a credit for that, that would cost you about $15. Because that's all it costs to do. Yeah, okay. Anyway, we do that a couple of times, and this is the plough that we use. This is my plough at home on its second pass, so it's already gone through the ground once, and it's just cutting through and removing the compaction and just going a bit deeper. This is being pulled by a 45 horsepower tractor, and it's currently being pulled at about 18 inches. So now our soil on the second pass is about 12 to 14 inches. We started off with 3 inches. Okay? So we've built up a little bit more than 1% increase in organic matter. We actually went from about what was about 3% up to about 7% in 1 year. So that's effectively, now think about that you've got you've say increased that organic matter content by 5%. That's effectively pulling 5 of you out of the bargain as far as taking care of 5 of your emissions per year on 1 acre. And you're still growing some beautiful grass-fed beef and keeping a farmer in a job, and doing it in such a way that it's got to be organic, because you can't do this, you can't build soil and spread fertiliser, spread nitrogenous or artificial fertilisers. It just doesn't work. Because those elements are antagonistic to the development of soil life. In fact, they replace soil life, because one of the reasons why we use water-soluble fertilisers is so that we can basically just use the soil as a medium to hold up plants, and we feed the plants water-soluble nutrients. That's basically the game. So the life in the soil is, not radically necessary. We also spray the soil. Well, we spray plants, but we forget that the plants are actually attached to the soil still. And so we spray plants with herbicides, and we spray them with pesticides, and we spray them with fungicides. There's animals, there's plants called algae that live in soils that get affected by herbicides. And there's also plants that get killed by herbicides, which remove the water from the soil. When we remove plants from the soil, we actually dehydrate the soil. Interesting, isn't it? We also, when we use pesticides, we kill a lot of soil organisms. Well, not all soil organisms are microscopic, and a lot of our pesticides are systemic. They're non-selective, so they kill everything. A lot of those organisms that are, like worms and like slaters and like all of those other things that are breaking down matter and putting it through some sort of process, chain of events. And then we've also got the worst of all, the fungicides. The fungicides not only affect the fungus on the plants that are growing because the plants are weakened, because they're being fed water-soluble fertilisers, but they're also killing the fungi in the soil. And when you kill the fungi in your soil, you really think the game's starting to be over as far as having a life in the soil. So we have to get all of that stuff back, because the soil. The soil organisms are pretty tough. They take a bit of a beating, but we do a heck of a lot of damage in removing these organisms. And it's interesting. I was even in an organic property the other day, and we found that their soil depth on an organic dairy farm was still only about 4 inches deep. And I said to the bloke, "What are you doing here? Why you got an organic dairy farm? You're growing pasture. It's all grass fed. How come your soils are only 4 inches deep?" And then he told me what he's doing. He's spreading all of his slurry all over the property, and he's doing it often. So he's putting basically water-soluble organic fertiliser out, and the plants don't need to go hunting for any food. It's all there on the surface. And the livestock are not being managed on the property, so the soils are being compacted, and so the root depth is limited by the compaction as well. So, like even on organic properties, we're getting this sort of stuff. And if we're putting that much material out, he's putting out enough material to feed about 2 feet of soil every year, which is pretty exciting when we look at that as the flip side of turning a negative into a positive. He's got a lot of potential to feed a lot of soil organisms and build a lot of soil. This is what we sort of typically do. We go along. This is a first pass with the plough, and in a paddock that hasn't been touched with a plough for maybe 100 years, when it was first turned into agriculture from forest. And you get a bit of a release. You get a bit more land actually straight away. You get a bit more surface area. Can you see how there's a bit of a flat area in between there? And so you can imagine that's still a bit compacted. And so if we get a bit of a rain burst, what water doesn't infiltrate down that groove actually runs along there, because now we've actually started to create these little earth banks that guide the movement of runoff water over the site. Now we do it in such a pattern that falls towards the ridge from the valley, and in doing so actually moves away from what nature would have it, which is where water falls at 90 degrees to a contour and always makes its way to a valley and creates deep soils there and puts all the water there at the cost of the water and soil of the ridges. So we do the opposite. We actually send the water that would normally go to the valley out to the ridge, just by the angle of ploughing. It's pretty easy. I do it by what I call the seat of the pants. And all of you here, I'm sure, could manage it, because I'm pretty sure that all of your internal gyroscopes are calibrated such that you know when you're going up a hill or down a hill. Am I correct in assuming that? That's basically the technique we use here. when we're driving, we get in a valley and then we feel like we've sort of touched, this is as touchy-feely as I get, you feel like you're falling towards the ridge. So, and then once you get out onto the ridge, you feel like you're staying pretty level. And then when you drive up into the valley, you feel like you're rising. And so in your wake, you've got these plough lines that are distributing that water whenever it falls. So if we're rising, then that means we're going up, which means that something's going to be going down, and so on and so forth. Very easy stuff. Oh, I don't need to sell Yeomans bloody ploughs. There's a few other ploughs out there that do a similar job. You've got plenty of machines here. There's nothing as good as a Yeomans plough, there's no doubt about that. But you can sort of get away with using a few other bits and pieces that are around. This is one of them. You can even use an old chisel plough. This is one for those of you who don't know. This is a chisel plough. You've probably got one of these in your backyard, one of those little hoe things, little prongs. That's a chisel. That's a backyard chisel plough. This is just one that's pulled by a tractor. And then you've got another non-inversion plough. They make a bit of a mess, but that's what Louis Bromfield used. They were invented by Graham Home in Texas, and they work extremely well. They just create a rough surface. You can build soil with them. Lovely stuff. You can see I'm very elaborate with my equipment. My next book, actually my first book, will be on 101 ways to use plastic 55-gallon drums. I'm trying to push the boundary there. I love the things. As like I said, I'm a big fan of plastic. All right, now we have to break the compaction, and that sort of shows in a very poor drawing what happens. And you sort of get this around the point of the plough, you get a lot of release of the compaction. And what it does is if we've got any soil life in that top part of the soil, it actually will fall down the groove and almost inoculate the inert subsoil. The only difference, as I say, between subsoil and topsoil is life. Subsoil is inert material. It doesn't have any life. So all we have to do is just use that mineral soil and add some life to it, aka organic matter or organisms, and then convert material into organic matter, and now we've got a living soil. And now we've got something that's pretty good, and that stores carbon and is a very, very, very stable source of carbon. Humus molecules will last for 5,000 years. Now, think about that compared to so-called geosequestration as a means of injecting carbon dioxide from coal-powered or coal power stations. You put that stuff in the ground. I mean, how stable is that going to be? Yeah, it's just a no-brainer to make soil to do this stuff. It's all there. It's very, oh God, I don't know. Anyway, I've got a few other bits and pieces just to convince you further about the need to act, just aside from everything else, as far as agriculture is concerned. This is from the Journal of Environmental Planning and Management in 2001, so it's not something new. It's been out for a while. It's a peer-reviewed paper, so we'll sort of half trust it, I suppose. And depends on who your peers are, I suppose, doesn't it? This is the annual external costs of modern agriculture. There's a few bits missing, like healthcare. But let's go down to damage to number 2, the damage to natural capital from air emissions of methane, ammonia, nitrous oxide and carbon dioxide. $17 billion per annum. Now I know that's only about 4 weeks Iraq spending, but it's still a fair bit that we're spending here. Let's go down. We've got we've got about 2.5 billion per year that's seen damage to natural capital that you have in water, biodiversity, landscape, etc., etc. The annual bill is something like $32 billion per annum. That's the cost of agriculture, modern industrial agriculture. That equals per hectare of arable and grassland about $76 million per hectare. So what's that? Whatever that is, divide that by about just give or take about 25 million bucks an acre. Not that much. That's about what Gunner's place is worth, I think. He's minting soil out there. He's really. You have to pay for the mud that comes off his place. Is that expensive? Yeah. Well, it's even more. It's not. He's actually. He should be getting credit because he's not contributing to this ridiculous state of affairs. Isn't that insane? Now, you wonder how long this insanity can continue. Now, another thing I wanted to have a bit of a talk about is carbon sequestration, trees or soil or both. Now, most of you will have, you probably suffer from some form of carbon guilt, as I like to call it. And some of you would go off and buy, you subscribe to some carbon guilt program where you pay your money and you offset your guilt, and everything's all right. You can consume your life away like you normally would. And anyway, people do that. You can do it for $264 a year, according to this program on the bottom here. This is actually, believe it or not, from a bank. And let's have a look at that. So this is for Australia, 24 tonnes of emissions per annum Australians emit of carbon dioxide equivalent. That's we're the second biggest carbon dioxide emitters on the planet, only behind Luxembourg. You guys are about 20 tonnes or something like that per person. Right. So now anyway, they reckon, and a lot of people reckon, a lot of you will be buying this sort of stuff. When you buy your Saab, you do this, or when you go on American Airlines, you do this and that. You'll pay for a few trees. Now, in the case of this mob, you'll pay $264 for 33 square metres of trees. Now, if my math's not that good, but 33 square metres of trees is 3 metres by about 10 metres, right? Am I right there? Yeah, seems right. 33 by 10 would be about 30, yeah, okay. Now, correct me if I'm wrong as well, that most people who plant trees will plant them at about a 9 to 12 foot spacing, won't you? Yeah, that's a sort of a standard spacing for planting forestry trees. So that means in that, I reckon you plant about 8 trees for $264. And dream on that's going to give you that's going to cover your butt of 24 tonnes of carbon dioxide. You are dreaming seriously. So that's a bit of a laugh, but at the same time, it's a bit of a problem that we have, because I'm exposing this to you here. One day, someone's going to put this on 60 Minutes, and people are going to be mighty pissed, and they're going to feel like they've been had. And there's going to be lots of other very, very good carbon sequestration programs out there, like of Carbon Farmers of America, which are providing a direct payment to farmers to sequester carbon in their soils. They're paying $25 a tonne for every tonne. So you're a farmer, you're building soil, you're getting paid $25 a tonne for every tonne of carbon dioxide that you sequester. That's the market price. So you sequester 25 tonnes, you're doing all right. You really don't have to do much else actually, apart from being a carbon farmer. Yeah, that's pretty cool, and that's pretty sensible. Trees take a long time to sequester carbon, as you can see from the chart on the side here. A standing crop of trees, just in terms of organic matter, that organic matter is 167 tonnes. A tree that's 60 foot tall takes a good 20 years to grow. And you're not doing anything else with that block of land, and it's probably a fairly good site that really should be in agriculture, not in forestry, right? So you're only getting that much carbon actually built up in the system. That's the residue of all of this work, okay? Some of it, obviously, there is an amount of carbon dioxide that's being pulled out of the atmosphere to build this, but when we're looking at what's the locked-in residue, there it is. Now, in prairies, in grasslands, we can build, in just a couple of years, 150 tonnes of carbon in soils in a very short amount of time. So nearly as much as you would in an area of trees, but in just a couple of years. And we're not kicking anyone off their land. We're actually encouraging them, particularly where we do a direct payment subsidy, to actually do this sort of thing. So, which is a great thing. I mean, we could use carbon farming as an opportunity to convert systems into what we would call real organic agriculture, not this pretend stuff, real organic agriculture. And very, very quickly. Now, I plant a lot of trees, and I believe in planting trees, but what we've got to do is provide some sort of balanced approach where we put trees into landscape for their landscape functions, for their climate modification and all of their other values when we use them. So my belief is that we should be focusing on our soils and putting in trees at the same time, but not covering our agricultural landscapes, as is happening in a lot of places in Australia, with carbon tax, with carbon gilt plantations, replacing agricultural communities and really not giving you that much bang for your buck. Now, because we're nearly out of time, well, that depends. This is Yeomans' property in 1968. All of these ponds are not in creeks. They're all within the first 3 orders of catchment. So all of your ponds, all of your reservoirs of water are in the 4th and 5th orders of catchment. So they're upsetting stream flows, and they're at the bottom. So they have to be pumped. Pretty dumb, really. We often forget that physics are for free, and gravity is for free, and that we've got landscapes, particularly in areas like California, we've got enormous opportunities to place storages at higher levels in our catchment, and therefore achieve the gravity from them, as opposed to having these elaborate pumping systems and infrastructure that's dependent on energy. You can simply turn a valve on and away you go. Can you envisage this with houses on it? Well, you're going to have to, because this property has just been sold for $40 million. And those of you who've done my courses would know we've talked about this because of this photograph here. Just go back to, see this pond here at the bottom? And I just remember that, and just have a look at all of the market gardens. Gunnar knows this story. His old baseball field is now a car park for a strip mall. There's your market garden. First the highest value food production area is always the one that goes into housing development. And then where that very large storage there, in fact the second largest storage in this whole layout, is now a subdivision. Now what's insane about this development, this newer one, is that they pump their water from 50 miles away and pump back their effluent another 50 miles away. Yeah. We've calculated that there's enough water on this 750 acres for 2,000 houses. So that actually, if you buy that as a development, 40 million bucks for 2,000 houses, they're pretty cheap lots actually, from Western standards. You know, Australia's a Western country. I think we've got a slightly higher GDP than you guys have. We call ourselves, kidding, as the 51st state. We have everything you have. You know, American pop culture is totally pervasive, such to the point that I was named after Darren of Bewitched. It's sad but true. I should have been Stephen. So it would have been, "G'day, Steve." Or Step. Yeah. Said I'm Dazza. Yeah. All right. Or Durwood. Yeah. Anyway, this property has now been sold, and it's been sold to a developer, so my prophecy has come true. And I hope to get home in time to go and have a talk to the developer, because I can imagine houses being across this landscape, and I can imagine it actually being a landscape that is independent in terms of its water supply. In fact, it would have a surplus and would be a pretty nice landscape. It would almost be like living on one of those golf course developments, really, except there's no golf course. You notice those golf courses, they've got so much water features, and they never use the water hardly. Yeah, anyway. So this business here, if we're looking at this from as a model farm, it harvests all of the water and then actually has a continuous flow of water out of the system, because it's changed the whole hydrology of this site, such that instead of the water just going through and flashing away, it's now increased the amount of available water in soil, so that there's always water moving through the system. It's like when one builds a swale, you know, the water, as Warren Brush said of his swales out at Quail Springs, Permaculture at Kiama. He said that, you know, when I built a swale, or before I built a swale, the water would come from the hill to the creek in about 10 seconds, right? Or a day or whatever. Now it takes 2 years. Because what we're doing here is we're rehydrating the system. And it's akin basically to what happens when a landscape is forested. Not only we're actually intercepting the runoff, intercepting the rain before it hits the ground, and then we're getting it infiltrating into the groundwater. And then creeks and rivers are actually being fed through the groundwater, not through overland runoff. That's actually how it's meant to be, folks. And this sort of system here mimics that to a degree, but does it in an engineering framework that we can also overcome any drought. There is no drought on this farm, even though the rainfall here is only 25 inches and totally erratic. Here in west of Sydney, there is no pattern to rain. It's at any time of the year. So it's a sort of an environment where you really need to have this sort of thing. And this is a system that's born out of necessity. Now, wouldn't you think that in California here, where you have drought every year, that it would be, if you guys didn't have the groundwater resources that you have, you would be doing this kind of stuff. And it won't be long before you won't have the groundwater resources that you have. That's certainly going to be the case. The time of replenishment is much slower than the rate of use. So don't be under any illusions there. But the good thing is that I've shown you this, and now you don't have any excuse. So it's just a matter of our policy people who come to these shows occasionally. I just did a show up in Marin County, and we had NRCS people there, and Natural Resource Conservation Service people there, and Farm Bureau people there, etc. And they were pretty happy with what they saw. But then you've got state water laws and all of that sort of thing to get past. Anyway, we'll just keep badgering away. You've got to vote for a guy called Brock Dolman to be on the water board, on the Water Authority up in California, and he'll get in there and stir things up. Yeah. So now Yeomans integrated trees into these landscapes in clever ways, which is quite good, which is a form of what we call energy capture. And you can see here again that we're using these systems so that we're holding the amount of energy through the system instead of having it all run off. Now, we use this key point locations. Key points are positions in gullies where the landscape changes from convex to concave. And that's the highest practical place in a valley that we can store water. And it's pretty high up in valleys. You'll see some here. You've all seen landscapes like that. I haven't got one of those fancy laser pointers, but I'll just point to it by... The key point in this valley is right here. Now you've got key points all through this town. My house in my town is actually built on a key point, but they've just got drainage so that I don't get inundated. But they are points all through landscapes. This is at Cambria, and this is a vineyard that's dehydrating a hill. And the crazy thing is they're pumping water from underground and then pumping it at high energy cost through this whole system, when in fact they could have built a storage at the top of this hill and another one in here, and they could have all been run by gravity using today's water, not 10,000 years ago's water. Yeah, not fossil water as I call it. Yeah, today's water. Actually using water that's fresher in the hydrological cycle, but instead they're drying the landscape out and creating an erosion. This is one of my favourites. This is up at Highway 101. I took a new photo of this today, and has anyone here got a spare $10,000? Because if you have, give it to me. I'll be good with it. I won't take any myself, because all I wanted to do was just go and knock on this farmer's door, and I wanted to go and build him a little dam right in that. See where it's green? Mm-hmm. Yeah? And see how there's erosion there? Yeah. What generally causes erosion? Water. Okay. So it would be a natural place to put a little storage in there. I could build one in there. I'll build it. I'll get on the bulldozer and I'll build it to make it cheaper. And we could go and build about a 5 or 10 acre foot pond there, and we'd be able to put some little wings in it which catch the water off the landscape, like some gutters, and draw that water that's otherwise falling off this slope. Scary things. And bring it into this pond, and then I'd put a pipe at the bottom of the pond, and then I'd let that water out. And instead of, this is the crazy thing, farmer going out of business because he's got no feed, and he's importing feed from Nevada or from Bakersfield or some bloody stupid place, and at very high cost. I was talking to a farmer yesterday. He's paying $16 per small bale. And I looked at I said, how much he used to spend? He spent $40,000. And he's an organic farmer, right? Organic farmer, and he's imported the hay from Nevada because, according to USDA regulations, he has to feed them certified organic feed. So there's all of this fossil energy built into this stuff, and then there's also a feed bill, right? So it's money. Now, with that little 5 or 10 acre foot dam there, I could irrigate a good probably 20 acres out of that just by turning a tap on. And I wouldn't have listless, hungry cattle. I'd have, knee-high bloody pasture. Yeah, right now when there's no water. So yeah, if you've got that 10 grand, just come up. PayPal is best for me. Although they take a little bit, don't they, PayPal? Yeah. So there's all of these sorts of positions in our landscape. Like that's another classic one there. You can just see it's, why is that bloody well green there? I mean, it's green because it's water, hello. And it's got some residence time there, and we just have to build a little pond there, which doesn't take up too much space. And then we've got something there that we can then irrigate some pasture with later. Now, the good thing about it is too, if we irrigate pasture, then we radically increase the amount of carbon dioxide sequestered as well. So it's got some, you've got some multiple benefits, what you would call synergies involved here. Yeah. So yeah, you'll know that's just north of, just south of Buellton. I stopped at it today. All of that valley now is just filled with hay and shit, because that's where in that beautiful valley, they've just continued to feed off this whole summer. So it's just a pollution zone, and no doubt all of these livestock from being fed there, shitting there, are probably all full of intestinal parasites in that constant cycle. And this, that's the sort of stuff that goes on out there that is totally unnecessary. Yeah. All right, these are some lovely scenes of Keyline properties with lots of water. Look at them all. This is another place. Another place where you can build dams is in the saddles of landscapes. They work really well. And here we go. Here's one of those that I've built on a saddle. And I built this one in '96. This is the height, this is on a ridge. Not all saddles you can build them, but we built one there. That's about, about $6,000 or something, that storage, about 5 acre feet. And we paid for that by about year 7. It took a little while to wait for that. Well, we actually paid for it in 2 years. We just had to wait for 7 years for the organic U-pick cherry trees to grow that are all irrigated via gravity from this system. The dam is actually fed by that ridge-lying road. There's no channels that are actually harvesting the water. It's the road runoff that runs down into the saddle. And how we first knew about that being a good place is, well, A, from looking at Keyline and studying our landscape, but also from looking at the erosion that was right there. Problem equals solution. We put in all of these pipes at the bottom of the dams. Here's me doing that in Vietnam. That's to actually let go of the water out of the bottom of the dam. And like I said, that basically turns the dam into a large cistern where we can empty it fully. We get as much water as we like out of the whole thing. Then we can irrigate a lot of land very quickly, or set it up to irrigate our stock troughs or drip irrigation systems, whatever you like. These are the drains that catch the water and then distribute it at rates of up to 100,000 gallons per hour plus. I know this is all black and white. You'd probably like to see something in colour, so I'll give you that. Here's one, and we're on a bit of a hill here. We're gonna have questions we're nearly at the end. These stops here, you stop it as the water's running along, and it just simply floods over the bank and irrigates the pasture below. Any excess is caught by another drain and then taken back into the next dam. So there's what doesn't infiltrate into the soil actually gets harvested. Very effective. You can see here a good example of a system not unlike that we saw just down the road here, where we've got we've got a valley, we've put a pond in, and then we irrigate about 20 acres of pasture. at a time of year when no one else has got anything. As you can see, this is not an unusual landscape to you. It's southern Australia, very similar. Again, you know, what's missing? Trees. But you can see there we're irrigating quite reasonable slopes without any problem, without any hazard, and getting an increase in production. This farmer, in fact, didn't need to buy any more land. You don't have to be a land accumulator like a lot of farmers have to be these days in order to increase production. They go and buy more land as opposed to increasing the production of the land they've already got. Yeah, it's about getting bigger and getting out. There's lots of lovely trees and all the trees, shelter belts and all of that, that's all necessary part of this. Different types of ponds, and we put ponds on ridges and all sorts of places and fit them in with our landscapes very nicely. Now, we send water all these different ways. The water actually runs pretty slowly. That's how fast it actually goes, about walking pace. So we're dropping a lot of the sediment out. As you can see here on my project in Vietnam, that's the sediment that's dropped out in the first year. So that's water, that's soil in water that hasn't gone off the site. And then we've cleaned that out with a grader. And in the first year we spent a week cleaning out all of the drains of all of the silt. That silt was then used in the million. We've got a tree nursery there that grows about 1 million trees a year that we set up. So that's all used for potting mix for that. So it's not wasted. Gets distributed again. And this, I just sent some money a couple of weeks ago for this project, and we did 3 days of grading this time. So the system is starting to not erode anywhere near as much, so therefore we're not having to clean the drains. The drain cleaning is really my indicator of how much silt we're getting lost off here. Yeah, now I could just keep going on and on and on with all of this stuff, but I think I'll just come back to this one here, and at our research station where we're doing a pretty nice job of integrating forestry into agricultural landscapes. This has actually got 150 species of trees in this system, in an arboretum of useful species, and about 120 odd species of pasture, all in a layout. And what happens is, can I do that? No, I can do without the bloody thing. That all of the water comes from that gully. Can you see the gully from the contours there? All of the water comes from the gully, and when it rains heavily, all of the water actually sits out here. So instead of the water making its way into the valley, we're actually totally rehydrating the ridges. So we're still getting enough water in the valleys to water them, but we're just getting a much more even flow of water over the landscape. And we're doing it in a way that all of the rows are actually equidistant apart, as opposed to this sort of chaotic pattern where we use contours. And this is a fairly common picture of agricultural landscapes across the United States where we've used contours. Contours actually, and these contour banks actually dehydrate the landscape. So you've done the soil conservation boys have actually, and girls have actually done a wonderful job of reducing the amount of soil erosion, but at the same time they've still continued to cause the dehydration of the landscape because the water still ends up in the valleys. It actually is directed to the valley by the pattern of use. And it's a very difficult pattern to actually use machinery on, which is another thing.